Hello friends, I am Krishna Kanjani from LG Institute of Engineering and Technology. Welcome to the online lecture series on kinematics and theory of motion. In this session, we will learn about cam and follower system. In previous sessions, we have learned various types of cam, various types of follower, and solve one numerical based on radial follower. In this session, we will learn that how we can draw cam profile for offset follower. Okay, so let's start this session with the numerical. In this numerical, it is given that a cam is to be given the following type of motion to a knife edge follower. So the first data that is given type of follower, that is knife edge follower. Outstroke, or we can say rise during the 60 degree, that is your theta 1, dwell 30 degree theta 2, then return 60 degree and rest of the dwell, that is for remaining 210, that is your theta 4. Now the stroke of the follower is 40 mm. So we can say that the displacement, or we can say the bottommost position to the topmost position, if you measure the distance, then it is stroke that is given as 40 mm. Okay, so let's consider this data. So lift, or we can say stroke 40 mm, theta 1 60 degree, theta 2 12 for 30 degree, then theta 3 is equal to 60 degree for the next return stroke, and for the remaining period, that is for the rest of the dwell, it is 210 degree. Okay, now the next data, the minimum radius of cam is given as 50 mm. So we can say that base radius, okay, so radius of base circle is given as 50 mm. The follower moves with uniform velocity during both the outstroke and return stroke. Okay, so focus over here. So the type of motion of follower is given as uniform velocity, or we can say UVM, and that is for the both the cases, for the rise as well as for the return. So we can say the motion is UVM, and the type of follower is knife edge follower. So we have to draw the profile of the cam when the axis of follower is offset by 20 mm. Okay, so be careful. This data is most important. If you will miss this statement, then you will plot the whole cam profile based on the radial follower, and that will be the wrong method. Okay, so over here you need to concentrate on these data properly, that it is offset by 20 mm from the axis. Okay, so now to plot the cam profile, we have to first draw the displacement diagram. So let's start with the displacement diagram. Okay, so now in this numerical, the angle is given, that is 60, 30, 60 and 210. So to represent it on a horizontal axis, we need to take scale. Okay, so let's start with the displacement. We have to take scale. That let's consider that 20 degree will be represented by 10 mm. Okay, so over here we have to plot the displacement diagram in which on x-axis we have to plot the one revolution of cam, or we can say angular displacement, or we can simply say that the theta, and on a vertical axis, that is for displacement, or we can say the stroke, or we can say lift. Okay, now to represent it on horizontal scale, let's consider 20 degrees equal to 10 mm. So here the total one revolution will be of 360 degree. So we can simply say that it is 180. We have to sketch a line that is of 180 mm. Okay, so we have to plot properly a horizontal line which is having length of 180 mm, that is representing the total 360 degree. Okay, and vertical line having the length of stroke, that is 40 mm. So draw vertical line of 40 mm. Okay, make complete rectangle to sketch the displacement diagram. Okay, now the first theta 1, that is for rise 60 degree. So 60 degree will be covered with 30 mm distance. Okay, if you will use the scale, then you can simply calculate that to represent 60 degree we need to draw a length of 30 mm. So over here you have to make first division of 30 mm. Okay, so this rectangle will cover up the displacement diagram for rise angle. Okay, now the type of motion during this rise is given as uniform velocity method. Okay, now we have learned that in UVM we have to simply divide this horizontal line into 6 equal number of divisions. Okay, so 30 divided by 6, so it will be a simple 6 divisions of 5 mm. Okay, so let's divide it into 6 equal parts. Okay, so 0, 1, 2, 3, 4, 5 and 6. Now simple UVM, uniform velocity method. So in this method we have to connect simply this diagonal of this rectangle, and that this diagonal line is representing the displacement diagram. Okay, so over here we can simply sketch that from starting from the O point to the ending point over here we need to simply connect this diagonal. Okay, so now intersection over here. So first intersection will give the first point, second point, third point, fourth point, fifth point, and the last one, the sixth point. Okay, now you need to give proper notations. Okay, so over here your notation will help you while you will sketch the while you are drawing the cam profile. Okay, so let's consider over here at starting point if we give notation as A, B, C, D, E, F and G point. Okay, so in this way you can sketch for the first half, that is for θ1. Okay, now second half, that is θ2. Now θ2 is dwell period, and we know that during the dwell period follower does not produce any type of motion, so it is a simple horizontal line. Okay, so over here if you refer, then from point G you need to sketch dwell period is for 30 degree, or it is represented as 15 mm. Okay, so make the second rectangle representing θ2 or dwell angle, and this dwell angle θ2 is represented by a simple horizontal line. So this connecting line will sketch the second part of the cam profile. So okay, so in this way we can plot simply the displacement diagram for θ1 as well as if you connect this rectangle, then it is your θ2. Okay, now θ3 case, that is the third half. Okay, now in θ3 the length is given as again 60 degrees, so we can calculate simply that it is of 30 mm. So we will again make rectangle at 60 mm 30 mm distance. Now this phase is producing type of motion of UVM. Okay, so again over here rise and return both are following by the uniform velocity motion. Okay, so we don't need to change any type of method. Okay, so we have to directly develop the mirror effect as we have developed of the sketch as we have developed in θ1. Okay, so to create a mirror effect from θ1 to θ3, either we can simply sketch horizontal line from the obtained points, either we can follow the same procedure for θ3, that is for uniform velocity. And the simple steps in uniform velocity is simply you need to divide the horizontal line into 6 equal parts of 5 mm, because the total length is 30 mm. So 30 by 6, that will give you 5. So you need to divide. You need to make 6 equal divisions of 5. Okay, now connect these points to the diagonal line, and this intersection will give you the rest of the points. Okay, now for θ4, that is for the rest of the period 210. Okay, now over here it is dwell, and in dwell the follower is not producing any type of motion, so it is simply a horizontal line. Now position of the follower is at bottom, so that's why your horizontal line is at the bottom. Okay, so complete this rectangle, and this will give you the displacement diagram of uniform velocity for this type of numerical. Okay, so in this way we can sketch the displacement diagram. Okay, now after displacement diagram we need to proceed for the cam profile. So let's proceed for the cam profile. So now over here as we are knowing that for cam profile we need this displacement diagram, so we have taken this reference over here. Now to sketch the cam profile, first procedure is to draw the base circle. Okay, so now base circle, so in this data they have given that the base circle radius is given as 50 mm. So step 1 is simply we need to draw the base circle that is of 50 mm. Okay, now on this base circle we have to draw the type of follower. Over here it is given as knife edge follower. So if you consider, then knife edge follower, but in radial case, okay, if you refer the previous numerical, so in radial type of cam and follower system, your follower is sketched over here, but over here in this numerical it is given offset by 20 mm. What it means? That the path of the follower is not passing from the center, it is offset by 20 mm, so we need to develop offset. Okay, so over here if you consider that 20 mm offset, okay, so the distance 20 mm is given as offset distance, so consider 20 mm distance as your offset distance, and from that point you need to plot the knife edge. Okay, so be careful, as we have the only first change that you need to consider while solving this cam profile for offset follower, that you have to plot one circle which is known as a offset circle, and this offset circle is having the radius as the distance given in the offset. Okay, so over here you can simply sketch like this. So in this way we can plot that the base circle that is having the radius of 50 mm, then the offset circle having the radius of 20 mm, and after reaching at the offset point we will sketch the knife edge follower. Okay, now next step, after sketching the position of knife edge follower and your cam, you need to connect this contact point to the center. So this connection of with the center point will give you the reference line. Okay, now this reference line is your starting point. From this starting point you have to sketch theta 1, 2, 3 and 4. So over here first theta 1, that is 60 degree. So from this you need to put your protector over here and make angle at 60 degree. Okay, so keep proper attention over here, that you need to put your protector on this reference line and measure the angle theta 1, that is of 60 degree over here. Okay, similarly 30 degree, so theta 2 will be 30 degree, that will be over here. Then theta 3 again 60 degree, so next one, that is theta 3, which is measuring again 60 degree, that is your theta 3. Okay, now after sketching theta 1, 2, 3 and rest of the period which is representing theta 4, now you need to divide this angle into 6 equal parts, because over here the horizontal line is divided into 6 equal parts for theta 1 and theta 3. So similar way you need to divide theta 1 and theta 3 by 6 equal divisions. So over here 60 degree angle is divided into 6 equal parts of 10 degree each. Okay, so we can simply consider that 10 degree rotation over here. So from reference axis 10 degree will be first division, 20 degree, 30 degree, 40, 50 and 60 representing your point number 1, 2, 3, 4, 5 and 6 that you have sketched in your displacement diagram. Similarly for the theta 3 period, or we can say for the return stroke, again we have to follow the same procedure, that divide your theta 3 angle into 6 equal divisions. Okay, now after sketching it into 6 equal divisions, okay, so you will get the divisions like this. So you will get the point from 0 to 6, then again from 0 dash to 6 dash point. Now next point is to sketch the tangential line. Okay, so over here you need to draw the tangent line, and the tangent line must pass from your origin point from the division. Okay, so if you consider for first case, that is for this one point. Okay, so for point number 1, if you want a tangent line, then you need to draw the tangent line which is tangent to this your offset circle. Okay, be careful, you need to draw tangent to your offset circle. So over here from your starting point you have to sketch this tangent point like this, and to sketch this tangent point simply put your protector in such a way that it's one of the side is passing is making tangent with your offset circle, and the second side is passing from your first point. Okay, so if you consider your 60 degree or 30 degree protector like this, so put your protector in this way so that you will get the tangent line directly. Okay, now for tangent line passing from point number 2, so put your protector in such a way that it is making tangent to your circle like this. Okay, so in this way simply rotate your protector, and this rotation will give you the tangent line passing from point number 1, point number 2, point number 3. Be careful over here, your each and every tangent will not pass from this starting point, it will continuously rotate. Okay, so it will be following curvature shape as your periphery of your offset circle. Okay, so similarly passing from the 6th point and tangent to your offset point. Similarly, you need to connect also draw the tangent point from for the theta 3 phase also. Okay, so in this way you will sketch the tangent lines. Okay, now after sketching this tangent line, okay, so which is following like this. Now after sketching the offset tangent line, now you have to simply follow the same procedure as we have done in our knife edge type simple radial follower. Okay, so what we have done in radial follower, that we have measured the distance from the displacement diagram. Okay, so now refer your displacement diagram. So in your displacement diagram you have obtained different points as A, B, C, D, E. Okay, so these points are measured from this 0 to 6 points. So similarly your 0 to 6 points are a sketch over this base circle. Now from this base circle you need to measure the distance. So for the first position, that is 0 position, A point is lying on the similar O point. So your first point of contact will make the starting point as point A. Okay, now for the second point, that is from 1 point. So from point number 1 to B. Okay, so measure this vertical distance from rounder. Okay, be careful, a simple procedure. Take your rounder, okay, put tip of your rounder on point number 1 and measure the distance from 1 to B. Okay, now take this 1B distance as your reference distance and the similar distance. Put your tip of rounder on this 1 point and make arc on this tangent point, which will give you point B. Okay, in this way. Similarly, you have to measure point distance 2C. Okay, so this vertical distance you need to again measure from your rounder. Put your tip of the rounder on point number 2. Make arc having the length of 2C. Okay, so this will give you point C. Then for again from the same procedure we can follow for 3D, 4E, 5F and so on. So okay, so in this way you will get different points which is measuring the distance from your displacement diagram and making arc on this tangent line, and that will give you point B, point E, point F and point G. Okay, similarly from point H, I, J, K, L and M and N point. Okay, so in this way you will get the complete points or the complete points of your cam profile. Okay, then you need to simply connect these points and that will give you the cam profile. Okay, so if you will sketch it properly, then it will give you the cam profile, which is representing the motion of the follower while one complete rotation of the cam. Okay, so theta 4. Okay, now over here be careful, your theta 4 period is your dwell period. So for this rest of the dwell period you need to join this starting point with the end point. Okay, so you have to connect this point from A to point B. It is mandatory. Sometimes students forget to connect this line with a dark line. Okay, so over here be careful, you need to represent this whole cam profile with the dark line so that it will be representing the proper shape of your cam motion. Okay, so in this way we can sketch the displacement diagram and cam profile for the offset follower. Thank you.